All right, class. I was hoping for at least a good, chorus of this because we don't have Denny here to messing up our choir. Okay, he's our lone baritone in here. He's the only boy in the class.
We had another boy, but he quit.
I'm not a boy. It's ma'am. Anyway. All right, so this video here is going to be for Denny, R.I.P. Okay. Actually, no, don't rest in peace because he's probably still in bed right now. I don't want you resting, Denny. You need to be watching this video in class. Find the equation of the tangent line to the graph at the point blah blah blah. All right. So first thing, tangent line implies that I need to do the what? I need a derivative. Okay, I need to do the derivative of this. So let's identify the parts because this is going to be chain rule, isn't it? Say yes.
Yes.
Good. It's going to be chain rule. So it's going to be, I'm going to say that my u, 4x is my u, right?
Yeah.
U prime is 4. And now I rewrite my original. So it's going to be 5e to the u. Right? Say yes.
Yes.
Meow. Are you lost?
No.
You're good?
I watched the notes.
I know, I'm just asking.
Oh.
You gave me that look again.
No, I looked up.
Okay, all right, good. All right, so now, can I take the derivative of that?
Yes.
Yes, I can. What's the derivative? So, meow, since you watched the notes, what's the derivative of 5e to the u? Yeah, there it is. Yeah, so it's going to be 5e to the u, right? Good. So, y prime is 5e to the u. Now, chain rule says derivative of the inside times derivative of the outside. Identified as my inside as 4x, right, is my u, and then, so derivative is going to be, so I'm going to take this one and multiply by 4, and then I'm going to end up with y prime is 20 e to the, now, what do I do? Do I keep that u there?
No.
No, I got to sub it back, right?
Yeah, the original.
Sub it back, so that's going to be
Or to that.
4x. There you go. So I now have the derivative, yes,
Yeah.
and I want the derivative where?
At point of
0, 5. Okay, so the important part of that, what do I need to take out of that point first? X value. So what am I going to do with the x value? Plug it in, right?
Yeah.
So it's going to be y prime 20 e to the 4 times 0. Anything times 0 is?
0.
Okay. Now anything to the 0 power is?
1.
1. 1 times 20? 20. Yeah. So my slope, so m equals 20. So, is this making sense? Okay, so let's go ahead and throw it all in there now. So, I'm going to have y minus what? 5, very good. 5 is equal to 20 times quantity x minus 0. And let's see if you can mental math this one. I know that last one was kind of difficult with the fractions and such, but this one's going to be easy. Y equals 20x. Wrong!
Plus 5.
Plus 5, because you're adding 5 to both sides. Plus 5. There we go. Not so bad, right? Not so bad. Each one is specific. You need to identify. It's a puzzle. You just pick out the piece that's going to make it work for each of these. When we actually do some integrations later on, because in math, for everything that we do in math, we have its opposite. We have something that undoes it. So, addition, I have subtraction, because that undoes it. Division, I have multiplication. Exponent, I have a root, right? I have a root. And then a derivative has a integral, which is going to be the opposite, to undo a derivative. All right. This one is probably one of the better ones that you're going to have. You're going to have a whole bunch of these like this all the time. Carbon dating. All carbon on Earth contains some carbon-14, which is radioactive. When a living organism dies, carbon-14 begins to decay at a fixed rate. The formula, P of T, it's all there, gives a percentage of carbon-14 present at time of T years. Notice that when T equals 0, the percentage of carbon-14 present is 100%. As you still are alive, you are still radioactive. Did you know that?
No.
Everyone is radioactive, slightly radioactive, okay? A little bit more than a normal banana. Bananas are also radioactive.
Isn't everything radioactive?
Somewhat. Okay, so now potassium is radioactive too, slightly. Anyway, see what I did there? See what I did there? Okay, is it bad? No. You need radiation to live. The sun cooks you with radiation all day long. You didn't know you go outside and get microwaved. Anyway, when the preserved bodies of 15-year-old La Donacia and her 2 children were found in Peru in 2005, 93% of the carbon-14 remained in their bodies, indicating that the 3 had died about 550 years earlier. What is the rate of change of the percent of carbon-14 in the 550-year-old fossil? Okay, I have 2 times that I'm going to have here. So I have my equation, which is going to be my, damn it. Okay, so my equation was P of T equals 100 e to the negative 0. What's it like, 4 zeros there? 1, 2, 3, 3 zeros. One, two, 1t. Okay. So the P of T refers to percent over time. Yep, right? Yes, percent over time. All right, so I have 2 locations where this is going to work. So first, I know that when P of 0, that's going to be 100 e to the negative 0.0001210. Anything times 0 is, say 0. 0. And e raised to the 0 is 1. Okay? So 100 times 1 is 100, right? So I have a time and a percent. So at time 0, my percent is 100. Does that make sense?
Mm-hmm.
Alrighty. So now, And now I'm gonna look at it, and I'm gonna go backwards. So the next point that I have is, I have 93.5. 93.5%, right?
Yeah.
And they say that's gonna be how old? 550?
Yeah, 550 years earlier?
Mm-hmm. Okay. So now, as I do that, can I find the slope in between these points? Yeah.
Yeah, you can.
Yeah. So what I did is I plugged in my known values, I got two distinct points, and the rate of change is just the slope. So I'm just gonna do the slope formula. So it's gonna be 93.5, that's a 0.5, minus 100 over 550 minus 0. I know you guys are doing amazing math right now, and you might need a calculator for this one. Because I'm not very good at, knowing how to calculate e to the negative 0.00121 times 550. Even though you don't have to do that, but you're still gonna end up having to do this, and I don't know what that is gonna be. So what's that gonna be, 6.5? Negative 6.5 over 550. Let's see if I can get this one. So, let me see.
Like a very long decimal.
Okay, so I'm gonna have, it is about negative 0.012. And in calculus, in AP calculus especially, we always round it to 3 decimal points. And so, if this is a slope, it's a rate of change, isn't it?
Mhm.
And so it's a change of what? What am I changing here? What are my two things that I'm referencing? What's
Present year
what's the P stand for?
percentage.
Percentage over time. Okay? And that's gonna be percent. So it's going down that amount per year. What is the rate of change of the percentage of a carbon-14 in a 2,000-year-old fossil? Okay, so it's now 2,000 years. So they give me time, but they don't give me percent. So again, P of we still know it is going to be 0 and 100. But now this time, what did they give us this time?
2,000 years.
2,000 years. So it gives me time. Does it give me the percent?
No, you have to find it.
I gotta find the percent. Okay. So this 2,000 represents which variable?
T.
My t, so can I just plug that in?
Yeah.
Don't wanna do that.
Oh, it's almost like I told you to take out the calculator for a reason.
I haven't, but I don't feel like typing those numbers.
Oh, you know what? I have your grade over here and I don't feel like passing you.
I don't know. Want it in a fraction form, or do you want it in a decimal form?
Give me a decimal.
Just give me a fraction. How do you put it into it?
I'm pulling it up. Give me a minute.
Okay.
And it depends on where you're doing it at. I'm just gonna do it regular scratch pad.
Doing it on a scratch pad.
Regular scratch pad. 100 e raised to the negative 0.000
1, 2.
121, open parentheses, 2,000, close parentheses, and hit enter.
Okay, close.
So what were you doing?
I think I didn't do close parentheses, or.
That's your original one then?
This is my original.
You get yours? Okay. I don't know. We'll mess with your settings. We'll default your settings here in a little bit.
Okay.
That's probably what the problem was. Anyway, so 78 point, what's that? 506. Let me see. P of 2,000. .506. My marker does not like me. Yeah. Because it makes my 5s looks like 8s. There you go. All right, let's go back. What is the rate of change for the percentage of this one? So I had to first solve for the y value, which I did. Yes.
Yeah.
And now I need to find the slope. So finding the slope is going to be 78.506 minus 100 over 2,000 minus 0. Control, divide. I think I have some lag in my board. They did, but it's laggy now. It works, but it's just slow as can be. Maybe because I have a super slow computer.
Negative 0.011747.
Round to 3.
Rounded to the thousands place, right?
Yes.
Is that what,
1, 1. Okay.
okay.
Now, and that's again going to be percent, right?
Percent over year.
Yeah, percent over year too. That means in between these two things, what does it mean the longer it is?
Or percent, like,
So in between 0 and 550 years, I get negative 0.012, right? And then if it's 2,000 years, it's now negative 0.011.
percent per year, which takes longer?
Is it? Yes.
Takes longer to decay?
Yes. Now, decay is actually half-life theorem. Half-life, radiation is a half-life thing. So it decays it logarithmically. So at the very beginning, it decays faster than over time. So it plateaus over time. So there's not much change in between the 2,000 and the 5,000 mark. So yes, it's a lot more years, but the decay is so much smaller. So it plateaus. It is logarithmic.
Them down as decay.
Okay. Leibniz notations often used for chain rule with algebraic results. Now, Leibniz, Gottfried Leibniz, the creator of calculus. Okay, good. Prime notation is often easier to use and work with when solving numerical problems.
Okay.
Yeah, that's basically it. Those are the two different ways of doing this. And it just shows you the different ways, and you're gonna have to read both ways and know. And let me go back to Leibniz notation, which is here. The du dx.
It swap places, doesn't it?
Du dx. So,
Oh,
yeah, so it's, here it is, right here. dy du, so the derivative of the outside times the derivative of the inside, du dx. So I took the derivative, so I u subbed here, and I took the derivative in terms of u. And then what I u subbed, what I replaced, I took the derivative of that in terms of x. And then I just multiplied the two together. That's what the Leibniz notation is.
That whole process.
Yeah, the whole thing, but you're gonna have to be able to read each one. So this one, I took the derivative in terms of u, so du dx, and then this is whatever I sub for u, I took the derivative in terms of x's.
So in the form of an equation, it just tells you what it looks like.
Yeah, so for each of those. Now, I'm gonna pause it up here, and I want you guys to take the next 15 minutes, and then we are going to work on some homework. So I wanna have a break because some people are trying not to fall asleep. All right, we're continuing here, because you're gonna need these next couple examples to be able to continue on your homework. So this one right here says h is equal to f of g. What that means is it's going to be f of g of x. So that's what the f of g means. So it means that it is going to be a chain rule. So that is going to be a chain rule. So let's start with g of x. So g of x, so I'm going to have the inside. So what's the derivative of the inside? So g of x,
Okay.
given that, find h of 1. So that means that I'm going to replace g of 1. So what's the derivative g of 1? So this is saying g prime of 1. And I'm doing the derivative of the inside, so this is my u portion. So the derivative of the inside is
Negative 3.
-3. And so I'm going to take this. So the derivative of the inside is -3. Okay? Now, derivative of the outside what's going on? All right. How high are you?
No, it's.
How are you? What day is today?
Wait,
It's Wednesday. It's Wednesday, my dude. Where do you go?
I don't have a first.
You want to stay here and learn some calculus?
Just leave.
Close my door, please. Thank you. Good times. All right. So, now that I'm completely off task now. Anyway, okay, so g prime of 1 is -3. And so the next thing I'm going to do is of the next one. So f of -3, so that's going to go in there. So it's the derivative of the inside, so it's -3 times the outside.
F prime of 1? Or is it just F of -3?
It should be of f prime of, there it is. Yeah, here it is. Sorry.
Okay, F prime of 1, okay.
F prime 1. So f prime of 1 is 1.
Yeah.
So the derivative of the inside times the derivative of the outside, right?
Okay.
So the two derivatives is going to be times this, which is going to give me -3.
And then you did the outside.
Yes.
Okay.
Okay. I know those are kind of a pain, because especially if we have it written like this, we call it the inside and then the outside.
Oh, you just multiply. So you rewrite it as like F prime times G prime?
Yeah.
Okay.
So the derivative of the inside times the derivative of the outside. So we should get -3 there, hopefully.
If they
All right. Now, you're going to need this one because these ones are coming up here soon. It's on your homework, and I'm pretty sure you guys might have seen some of these so far in the 30s. No?
I'm at
Maybe? Okay, yeah. So, the derivative of a to the x. Now, the difference here is this one, my variable, is in the exponent. My variable is in the exponent. We've done this a little bit with the e's, you know, like e to the x, but now we're doing it with anything as my base, and my exponent is going to be my variable. And so by taking the derivative of that, I get a to the x times ln a. That's it, right?
natural log, right?
Yes, ln is natural log. So let's just use that formula we just did. So what's going to be on the outside? So my f prime is
Your F prime is like
2 to the x
okay.
ln of
2.
2. Super easy, right?
Hopefully.
Yeah, it sucks actually doing the math for this, to getting it down to this, but this simplifies to this point here. All right, so let's do the next one. And with the negative, I'm going to rewrite it. I'm going to rewrite it. So up front, so my f prime of x is, so it's 3 to the negative x, right?
Yeah,
But what if I want my x to be positive?
3, 1.
Okay, because to make the exponent positive, I would move it down, right?
Yeah,
That's -1, isn't it?
yeah.
So, like
Okay,
that?
So you take the whole thing down.
Yes. ln. ln 3. So, I'm checking my notes to make sure that they did write it that same way, because I don't like having the negative exponents. And usually, in the text, they don't like negative exponents either. So they rewrote that. Yeah, same thing. They just rewrote it. All right, C for this one right here.
No.
Okay, and then G prime. Take the derivative of this, it's going to be
Oh, it's the opposite way, okay.
1/2 u ln of 1/2, right?
1/2 is u and out, and 1/2 and
Times 2x. So hopefully that's not too crazy.
a little.
Yeah, the ln's gonna cause a slight issue though. The 1/2. Anyone remember the rules for ln's? Natural log rules about having fractions inside?
No, I only remember like some log.
So ln 1/2 is the same as saying ln 1 minus ln 2.
Okay, it's not, it's like log subtraction.
Yeah, so it's ln and logs are the same. So log is base 10,
Base 10.
where ln is base e.
Oh, yeah.
And because of this piece right here, this ln1 is always going to be, anyone remember what that is?
0.
Yeah, it is 0. ln1 is 0.
Because ln e is 1 and then
Equals 1, so that's e to the 0 powered is 1.
Yeah, e.
Okay, so that's going to be 0. That's ln2. So what else did I have there? I had, so I could replace that with ln -2. Oh, I'm sorry, minus ln2 there. There's a whole bunch of stuff you could actually do to keep rewriting this as different things. Yeah. Anyway, but when you're looking in the back of the book, they separate it.
They separate.
Yeah, they separate it so you could actually have different parts to it. Alright, so before we actually go too far into this, I need to correct my mistake because I got distracted. I gotta correct this mistake.
Oh.
I had it all down, I just wrote it out. G prime of this times this. Okay. So this is your composite function. So write down this formula to go along for these composite functions.
Is there another parentheses?
Huh?
Okay.
So, yeah, oh wait, another parentheses right there. You're right.
Okay, got it.
So I had the derivative inside, but I messed up derivative,
Outside.
yeah.
Okay.
So now if we're gonna do it as 1, it's gonna look like this. It's gonna be f prime of g of 1 times g prime of 1.
Okay.
Oh, like crackheads walking in, not even knowing what day it is. Weird. Don't talk to strangers. All right, so g prime of 1, that one was easy, right? That was 3, or -3.
-3
All right, g of 1,
is 2.
g of 1 is 2, right?
Yeah.
It's right here. G of 1 is 2. So this says f prime of
2.
2, right?
Which is -4.
Okay. So f prime of 2, which is,
-4.
yeah, -4, I'm sorry. I knew you're right, I'm just trying to find it on the thing. So it's gonna be -4 times -3. Yeah.
It's same with the graph one, it's just.
Yeah, it's finding it. So, anyway. So this is the formula that I messed up when I was just distracted.
I like.
Anyway.
Just jump.
Anyway, all right, so that being said, we will finish the rest of this on Friday. So make sure you all like, share, and subscribe, hit that notification button, support my channel. Thank you, Denny.